Hi and Assalamu alaikum. My name is Mama Khaira bin Sari, and in this video we are going to present for the experiment 2, which is computation of line parameters using MATLAB. So before that, I would like to introduce my team members. The first one is Satish Another Rao, Sivinesh Analaki Balachandran, and we are from session 4, group 2 and slot 3. So now I will proceed to the exercise 1, which is this is the question for the exercise 1, and then this is our manual calculation that we have done for the exercise 1. So for the radius that we obtain is 0.0560 feet, and for the geometry mean radius we get 0.0444 feet, and for the geometry mean distance is 44.0972 feet, and for the inductance of phase is 1.3802 millihenry per kilometer, and the last one is capacitance of phase, which is 0.0083 microfarad per kilometer. And after that, this is our MATLAB result for the exercise 1. As we can see here, for the geometry mean radius, which is 0.0444, which means same as our question that we have done, and same goes to the inductance and also capacitance, which is for the inductance in the MATLAB is 1.3802, and capacitance is 0.0083, which is same as our manual calculation that we have done. I think that's all from me. Now I will pass to my team members to continue the presentation. Thank you.
Hello doctor, my name is Satya Sanafanand Rao, metric number CE200206. So I'll present about exercise 2. Exercise 2 is that the transmission line is replaced by two ACSR 636,000 CMIL 24/7 root conductors which have the same total cross-section area of aluminium as one Britain conductor. The line spacing as measured from the center of the bundle is the same as before and is shown in figure 2. The conductors have a diameter of 0.977 inch and a diameter of 0.3924 inch. So the bundle spacing is 18 inch. So we need to find the inductance and capacitance per phase per kilometer of line and justify the result using MATLAB. So this is the given figure 2. So we have coded the coding into the MATLAB. As we can see here, DAB equals to, we need to enter the DAB value. For the DBC, we need to enter the DBC value. For DCA, we need to enter the DAC value. For the GMT, the formula is DAB times DBC times DCA bracket uh, uh, power of 1 over 3. For the diameter, we need to enter the conductor diameter in inch. For the radius, the formula is diameter over 2, and the D equals to enter the bundle spacing in inch. For DS, we must enter GMR DS in inch. For GMRL, the formula is square root of D times DS over 12. For GMRC, we need to square root D times R over 12. It will display the value of L in mH per kilometer. And the formula for L equals to 0.2 times log bracket GMD per GMRL bracket. And it will display the value of C in UF per kilometer. So the C formula is 0.0556 over log times GMT over GMRC. So after we run this coding, we found that the value of L equals to 1.0588 and the value of C in UF over kilometer is 0.017. 0.0107. So we came to conclude with our manual solution. We got the same answer, L equals to 1.0588 mH per kilometer, and the C value equals to 0.0107 UF per kilometer. So that's all from me, doctor. Thank you.
Hello, doctor. I'm Sivanesh Palachandran, metric number CE200215. Today I will be presenting on question 3. So, question 3, the conductors have a diameter of 1.427 inches and a GMR of 0.564 inches. The bundle spacing in 18 inches. We have to find the inductance and capacitance per phase per kilometer of the line and justify the result using MATLAB. So moving on to the manual solution. So these are the phase group of GMR. So this is the formula of DSA, DSP and DSC. So the formula of GMRC is here. Uh, with the formula of GMRC, we have to find inductance and capacitance. So inductance equals to 0.2 ln GMD over GMRL. So the capacitance is equals to 2 pi over ln GMD over GMRC. So with the formula, we can calculate that uh, inductance is 0.4491 and capacitance is 0.0254. So in order to find this, we have to replace the RA, RB, RC value in GMRC. So moving on to the MATLAB result to prove this manual calculation. So after running the programming, we will we have to enter the row vector of S. So the row vector of S is 11, 11, 16.5 and 12.5. So next the H row vector. H row vector is 7 and 6.5. Next, next is the bundle spacing inches, which is 18. Conductor diameter in inch, 1.7, 1.427. Geometric mean radius in inches, 0.564. So after entering the values, we will get the value of GMD, GMRL, GMRC, L and C, inductance and capacitance, which prove we have the manual solutions answer and the coding answer is same. So that's all for me. Thank you.